Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a mind-blowing achievement. A WebAssembly compiler that's, get this, smaller than a tweet.
Whoa, seriously? A WebAssembly compiler that small? That's insane! What's the trick? Some kind of crazy bit manipulation magic?
It's a combination of clever coding techniques and a deep understanding of WebAssembly's inner workings. The initial version was 269 bytes, but they managed to shrink it down to a mere 192 bytes. It compiles arithmetic expressions written in reverse Polish notation, or RPN.
RPN? That's like super old school, right? Stack-based calculations?
Exactly. And the genius is that it directly generates the WebAssembly bytecode, bypassing any higher-level abstractions. Think of it as handcrafting the machine code, but for WebAssembly. No fancy libraries, just pure, efficient bytecode generation.
So it's basically writing the WebAssembly binary directly in JavaScript? That's intense. How did they even manage to make it readable, let alone functional?
That's the real story. The article walks through a step-by-step deobfuscation process. They started by simply formatting the code, making it slightly more digestible. Then, they tackled the assignment expressions, which were used to save bytes and reuse variables in clever ways. They replaced single-letter variables with more descriptive names, making the logic much clearer.
I see. So it's like peeling back the layers of an onion, revealing the core logic with each step. What other tricks did they use?
Oh, there were tons. They used sparse arrays to save bytes by representing zeros implicitly. They also exploited the fact that JavaScript's assignment operator is an expression, allowing them to chain assignments and avoid extra statements. They even used tagged template literals for string splitting, which is a pretty neat trick.
Amazing! It sounds like a masterclass in code optimization. Did they use any other particularly interesting techniques?
Absolutely. They cleverly handled arithmetic operations by using the index-OF method on a string of operators, adding an offset to get the corresponding WebAssembly opcode. They also made assumptions about the size of numbers, using a 7-bit encoding which limits the range of numbers the compiler can handle.
So it's not exactly robust, but it's incredibly compact. A trade-off between size and functionality, I guess. What about the WebAssembly module itself? How's that structured?
The article breaks down the WebAssembly bytecode array, explaining each section: the magic number, version, type section, function section, export section, and code section. It's a detailed look at the low-level structure of a WebAssembly module. It's really fascinating to see how all the pieces fit together.
It's incredible how much they were able to pack into such a small amount of code. It's a testament to the power and efficiency of WebAssembly, and also a great example of clever programming techniques. This is definitely worth checking out for anyone interested in WebAssembly or code optimization.
Absolutely. And if you want to delve even deeper, the authors have a book, WebAssembly from the Ground Up, which promises a more in-depth exploration of the topic. It sounds like a fun read. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of tiny WebAssembly compilers. Have a great day.
Bye-bye.